Welcome back to Teliteroan. Let us continue. The speed of sound in air depends on wind conditions, temperature, and humidity. Speed in dry air at 0 degrees Celsius is about 330 meters per second. In water vapor, it is slightly faster. And in warm air, it is faster than cold air. The speed of sound in air also is 0 degrees Celsius. Speed of sound in air increases by 0.6 meter per second. Speed in water about 4 times speed in air, and speed in steel about 15 times its speed in air. Reflection of sound. Reflection is a process in which sound encountering a surface is returned. It is often called an echo. Multiple reflections are called reverberations. Reverberations are best heard when you sing in a room with letter A. Carpeted walls, B. Hard surface walls, C. Open windows. The answer is rigid walls better reflect sound energy. Fabric is absorbent and open windows let sound energy escape from the room. Consider a person attending a concert that is being broadcast over the radio. The person sits about 45 meters from the stage and listens to the radio broadcast with a transistor radio over one ear and a non-broadcast sound signal with the other ear. Further, suppose that the radio signal must travel all the way around the world before reaching the ear. Which signal will be heard first? Here are your choices. Radio signal, non-broadcast sound signal, both at the same time, or none of the above. The correct answer is radio signal. A radio signal travels at the speed of light, 3 times 10 raised to 8 meters per second. Therefore, if you sit further back at the concert, the radio signal would reach you first. Refraction, on the other hand, is the bending of waves. It is caused by changes in speed affected by the following. One is wind vibrations, and the other is temperature variations. A lot of people love to sing inside the bathroom because of privacy. A study conducted noted that people would open their mouths wide when they sing in private places like the bathroom. Another reason is that the hard wall surfaces of the bathroom, usually made of wood or tiles, brings about multiple reflection of sound. These hard walls or surfaces and the small dimension of the bathroom typically create an orally pleasing acoustic environment with many echoes and reverberations, contributing to the fullness and depth of voice. Well, this may not be the effect in the outside world though. Just like any other wave, sound also exhibits reflection. Reflection is usually described as the turning back of a wave as it hits a barrier. Echo is an example of a reflected sound. Reverberation, on the other hand, refers to the multiple reflection or echoes in a certain place. A reverberation often occurs in a small room with height, width, and length dimensions of approximately 17 meters or less. This best fits the bathroom, which enhances the voice. Echo sounding is another application of sound reflection. This is used by scientists to map the seafloor and to determine the depth of the ocean or sea. This is just the same as how bats use sound to detect distances. What about you? Can you identify other applications of sound reflection? Have you ever wondered why often failed concerts are usually held during nighttime? Having concert at night gives a chance for everyone to see and enjoy the live show because there is no work and no school. Sound also contributes to the scheduling of concerts. Usually, sound is heard better in far areas during nighttime than during daytime. This happens due to what is known as refraction. Refraction is described as the change in speed of sound when it encounters a medium of different density. As to what you had earlier, sound travels faster in hotter media. This change in speed of sound during refraction is also manifested as sort of bending of sound waves. When sound propagates in air, where the temperature changes with altitude, sound bends towards the hotter region. In this case, refraction happens. The refraction is due to the different refractive indices of air because of the difference in temperature. At daytime, when the sun is shining, the air near Earth's surface is cooler than the air above. You learn that sound travels faster in hotter medium. Since Earth's surface is cooler than air above during daytime, then sound would have moved from the cooler region towards the hotter air. Thus, sound waves will be refracted to the sky. At nighttime, the air near the Earth's surface is heated by the heat emitted by the ground, making it hotter than the air above, which is cooler due to the absence of the sun during nighttime. This makes sound move from the cooler air above towards the hotter air near the Earth's surface. Thank you for your active participation. I hope that you learned a lot. This has been Sir Gypsy Corpus of Camp Tino National High School. See you again next time. Goodbye.